Hello everybody. Today I am going to show you an amazing experiment on dynamo and motor. In the previous video we explained what is the difference between dynamo and a motor. Today I will just show you the function of dynamo and motor, how it works. You see, this is a DC dynamo and this is a DC motor and this is a DC dynamo. In the previous video we have explained how the DC motor and DC dynamo works, and I will show you today a demonstration how it works. You see here that this is a DC motor, and DC motor works on the principle of Fleming's left hand rule. Here you see this is a battery of 9 volt Nipo gold. This is a battery of 9 volt. We'll show you how electrical energy is converted into mechanical energy in DC motor. You see here we have taken this wire. I connect this positive with this one, and we have taken another wire, this one. I connect it with the negative terminal of the cell. Right? Now we'll connect this with this motor. First of all, we'll check this one whether the wires are in good condition or they will work or not. First that I will check. After that I will show you the functions of motors and dynamos. Let us check the wire first whether they are in perfect condition or not. After that, yes, it is okay. Now we'll check this one, this wire, and see whether they are in perfect condition or not. Yes, I am checking the continuity test of this wire. Yes, it is working. Now I will connect this with this cell. This one, and connect this with the negative terminal of the cell. Connect this with the negative terminal of the cell, and now I will test the motor. You see, this is one of the motor. You can see here. Let us check whether it is working or not. You see, we have taken this one and taken this propeller, and let's see how it works. Now you see, we will put it in a box so that we may demonstrate it very clearly. You see, we have taken a stand here. We'll fix this one here and we'll see how it works. We have taken a cell, two connecting wires, a motor and a propeller, or what you can say it as a fan. And now I will fix this one on the top of this packet, and we'll see whether it is working or not. Let's see how it works. We'll take this one and put the motor here. I'm putting this motor on this. Here you see, we are putting this motor on this side, and let's see how it works. You see, we are putting the motor here. Here you see, we are fixing this motor on this packet. You see, we are fixing the motor so that we demonstrate it very clearly how it is working. You see, you here we are demonstrating this one and putting this motor here, fixing this motor here, and I will check how it is working. Right, we have fixed this one. Now you see how it works. Here you see, we have taken this one, and if we put a switch in this so that it will work properly, and after that you can see how it works. Let us take a switch. Here we are taking a switch and connect it with this switch so that the fan may works in a better way. Right, here you see, we have taken a switch here. You can see here, this is a switch, and we are putting this switch on this wire, one wire. You see here, we are putting this switch on this wire, and with connecting wires, another connecting wires, we'll connect this switch here. You can see here, right. After that, if we put this one, let's see whether it is working or not. Here we are putting this one, let us fix this one in a proper way so that it may be fixed here. Now we are fixing this motor here, and we'll check whether this is working or not. Now if we switch on this one, let's see whether it is working or not. You see here how the fan is working. You see, this is a switch. If we switch off, the fan stops rotating. See here, again we are switching on. and you see how it works. You see here the fan is rotating. That means this is a motor, and you see here how it works. Here you see this is a cell, this is the motor, and this is the propeller. The fan is rotating. That means this one is electrical energy. And here you can see that electrical energy has transformed into mechanical energy. You see here this is rotating, and this is the function of a motor. It converts electrical energy into mechanical energy. You see here, you see again we are trying. You see here the fan is rotating. That means it is changing into mechanical form of energy, right? You see, and we have already explained that. You see here the fan is rotating, and here you see electrical energy has converted into mechanical form of energy. And we already explained that in DC motor, the DC motor works on the principle of Fleming's left hand rule. Here you see this is the left hand rule. Here you see I am explaining it here, and you switch off the fan and it stops working. And you see this is the Fleming's left hand rule, and you see here there are three fingers. One is thumb, the forefinger, and the middle finger. If they are mutually perpendicular to each other, this one, the forefinger, represents the magnetic field, direction of magnetic field. The middle finger represents the direction of current, and the thumb shows the direction of force, right? And in this way, the motor works on the principle of Fleming's left hand rule. That is, there are two laws behind this one. First one is that electrical energy is converted into mechanical form of energy. This is the function of this motor. That is, motor is a device which converts electrical energy into mechanical energy. See here, we are again showing you how it works. You see here how the fan is rotating, that is electrical energy is changing into mechanical energy. You see here electrical energy is changing into mechanical energy, and this works on the principle of Fleming's left hand rule. These are the functions of this motor. The first function, that motor is a device which converts electrical energy into mechanical energy. This is the first function of a motor. Not only that, a motor works on the principle of Fleming's left hand rule. We have already explained the Fleming's left hand rule, that is this one. This is the Fleming's left hand rule. You see here, this is the forefinger, this is the middle finger, and this is the thumb, right? You see here, this forefinger represents the magnetic field, direction of magnetic field, and this middle finger represents the direction of current, and the thumb represents the direction of force or motion. In this way, the motor works. I have already explained the functions of motor. You see here, again if I switch on this one and you see the fan is rotating. Here you can see that electrical energy is converted into mechanical form of energy. This is the function of a motor. Now I'll explain that is what is a dynamo, right? It's, you see this is a dynamo, and how it works that I am going to explain. First of all, see this that motor. That is, what is a motor? A motor is a device which converts electrical energy into mechanical energy. Not only that, a motor works on the principle of Fleming's left hand rule, and I have explained, and again I am explaining that if the three fingers, that is thumb, the forefinger, and the middle finger are in mutually perpendicular to each other, then the thumb represents the direction of force, the forefinger represents the direction of magnetic field, and the middle finger represents the direction of current. And this applies to DC motor. Dear friends, now I am explaining what is a dynamo, right? Again I am explaining, a motor is a device which converts electrical energy into mechanical energy. Not only that, it works on the principle of Fleming's left hand rule. Now I am explaining about dynamo. You see here, we have set this dynamo in this form. This is our dynamo and this is a rotating wheel. When we rotate this wheel, current will produce here and make the LED glow here. Let us check whether it is working or not. The first reason, the first definition is what is a dynamo. A dynamo is a device which converts mechanical energy into electrical energy. You see, if we rotate this wheel, it will convert the mechanical energy into electrical energy. That's why this LED will glow. Let us check whether they are working or not. Not only that, a dynamo works on the principle of Fleming's right hand rule. You see, this is our right hand rule. If the three fingers, that is middle finger, the forefinger and the thumb are perpendicular to each other, then this forefinger represents the direction of magnetic field, the middle finger represents the direction of current, and the thumb represents the direction of force or motion. In this way, the dynamo works on the principle of Fleming's right hand rule. This is the difference between a dynamo and a motor. You see here, this is a dynamo. Whenever we rotate this wheel, this mechanical form of energy is changing into electrical energy, and you see how it glows. Let us try it whether we can make electrical energy or not. You see here how we are rotating this wheel and whether we'll check whether this LED will glow or not. You see here how mechanical energy is changing into electrical energy. Whenever we are rotating this wheel, this mechanical energy is changing into electrical energy. Not only that, it works on the principle of Fleming's right hand rule. This is the function of a dynamo and a motor. This is the main difference between dynamo and a motor. A dynamo is a device which converts mechanical energy into electrical energy. See here how the rotating wheel is changing into electrical energy, and that's why the LED is glowing. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.